Okay, so it's time to start the symposium. Good afternoon. My name is Hirofumi Nakayama of Kyushu University. We appreciate your attendance at the International Symposium on the latest trends in digital transformation for the waste management and circular economy. This symposium organized by the Japan Society of Material Cycles and Waste Management and Korea Society of Waste Management. I'm going to be the chairperson together with Professor Zhang from Korean Society of Waste Management. We are truly grateful for the collaboration of our co-organizers and the dedication of the 6 presenters and the support from everyone who has contributed to make this event reality.
Yeah, my name is Yongchul Zhang from Korea Society of Waste Management. I'm a vice president and international chair of Korea Society of Waste Management. Thank you.
Before we officially start the symposium, we would like to invite both the presidents of the Japan Society of Material Cycles and Waste Management and the Korea Society of Waste Management to deliver their opening address. First, I'd like to invite Dr. Masahiro Osako, the president of Japan Society of Material Cycles and Waste Management. So please welcome Dr. Osako.
Good afternoon, everyone. Thank you for coming here today. Yes, and my name is Masahiro Osako, the president of the Japanese Society of Material Cycles and Waste Management. And on the occasion of the 34th Japanese annual conference and this international symposium. Yes, I would like to say a few words. And first of all, yes, I would like to express the sincere gratitude to all participants, especially Professor Zhang from Korean Society and other colleagues. Yes, and thank you for long time kind cooperation. Yes, and also, I strongly appreciate the Japanese members of conference committee for dedicated contribution to the preparation for this conference. Thank you very much. By the way, Japan's environmental policy currently aims to achieve a sustainable society based on the philosophy of carbon neutrality, circular economy, and nature positive. In our field, the circular economy in particular has become a major global movement. And DX, digital transformation, the theme of today's symposium is a powerful tool for realizing the circular economy society. We are very pleased to have distinguished speakers from Korea, China, Cambodia, and Japan at today's symposium. They will share very useful information. I hope that this symposium will provide an opportunity to deepen our understanding of DX for future economy. Thank you so much.
Next, I'm going to invite the opening greetings from Korean Society of Waste Management.
Unfortunately, our president, he's in the airplane right now. He took the plane from Seoul. He's on the way. Sorry for the missing, but I'll make a congratulatory remark for him. Dear ladies and gentlemen, it's my great honor to give a congratulatory remark for the 34th Annual Conference of Japan Society of Motorcycles and Waste Management and Three Rings Autumn International Symposium. I warmly welcome everyone to this symposium and thank you all speakers and guests. I hope this symposium could serve as an opportunity to bring about intra networks to all professionals and academia, including students and junior scientists, and promotes communication in the field of resource recirculation and energy recovery. The symposium will be full of enthusiast interactions among participants. As two societies have cooperated so far, this symposium is also organized by two societies this year. Its title is the International Symposium on Latest Trends in Digital Transformation for Waste Management and Circular Economy. Just as the global economy and logistics are interconnected, so is the resource circulation. The main theme is appropriate and timely for not only to country, but also the rest of the world right now. I hope that the symposium will provide a great vision that overcomes global challenges on circular economy. Lastly, I'd like to express my sincere appreciation to all those who contribute organizing this event, including President Dr. Osaka, Chairman Dr. Nakayama, and Dr. Zhang. And I hope all attendants would enjoy your staying in Osaka, and thank you very much. Dr. Jae-young Kim from President, Korean Society of Waste Management, Executive Vice President for Research, Seoul National University. Thank you.
Thank you for the opening remarks. Now let's move on to the symposium. Today we have 6 presentations, and each presenter will have 15 minutes for the presentation. We will ring a bell 1 minute before the allocated time, and again, second bell at the presentation, end of the presentation time. So please cooperate accordingly. Due to the time constraints, the Q&A session will be held collectively after all 6 presentations are finished. So firstly, I'd like to invite Professor Toru Kamo from Waseda University. So please welcome Professor Kamo.
Thank you very much for inviting me. It's an honor to me to have this kind of opportunity. Thank you very much. So first of all, I like to talk about recycling of organic resources using information technology. Okay. So at the beginning, I like to say, so that I'm studying the plastic recycling. At this moment, I like to show the DX is very important for the plastic recycling. So, okay. And I pick out the 4 topics here. Oh, okay. Okay. And hi. And can I use the laser point? Okay, I pick up the 4. So green gas the reduction and the microplastics and the circular economy and SEDs. So I don't have enough time to explain everything, but everybody here really understand how important these kind of topics. But anyway, so we understand the plastic recycling very important. So why plastic recycling important in the zero carbon society? Okay. So this is the energy diagram of the plastic recycling. So this is crude oil. Okay. So the 1 kilogram of the crude oil and 1 kilogram of the plastics and pellet and the new plastic products and waste plastics. So if consider the enthalpy, this is the recovered energy incineration. So that this is almost same. Of course, except the plastic might be include the oxygen, a little bit different. But if consider the hydrocarbon, 1 kilogram of the enthalpy of the 1 kilogram almost same, like here. Okay, but we spent a lot of we putting the huge energy to synthesize and purified. Where this energy go? So because we spent this energy reduced entropy. Okay, so the energy level gives energy level increase like here. But we cannot use entropy to recover the energy, something like that. It's impossible. Only way we can, so that to keep the quality or to keep this structure, chemical structure, this is the only way we can do that. So this is the reason why that we use the material recycle is very important. If the waste plastic is the energy of the waste plastic is decreased like here by contamination and the mixture something other things. So that time we have to put the energy for the recycling. So even though the recycled much better, but problem is we have another way, energy recovery here. So energy recovery is the very cheapest way, in very easy way. Of course, even that time we understand recycling much better, but the people like to go the easy way. This is the reason why most of the waste plastic, unfortunately, insulated and to go to the energy recovery. But now we go to the zero carbon society like here. And this is completely different. So the most of every hydrocarbon must be produced with the carbon dioxide of the air. Okay, the carbon dioxide only the carbon resources. So it means that if we like to make the product, we put the energy. So if we use the plant, we can make the biomass. If we use the catalyst of some drugs, so we have to use the CCU. So anyway, we have to put in the huge energy, the huge cost. So in zero carbon society, is energy recovery is very expensive. So this energy recovery very expensive than this chemical recycling. So chemical recycling is much better, but the easy way and the cheaper way than the energy recovery. So this is in the zero carbon society, recycling is very important, not only the environment, but also the economical point of view. That's a very important point for the recycling. Okay. And why DX used for the recycling? So we have, and this is the mixed plastic is the garbage. Everybody knows that. But if we separate them, they become the resources. Everybody knows that. But however, if we didn't mix them, they are materials, okay? So this is the one typical example. A grain of the sand falling in the desert. That is very difficult to recover. So we cannot do that basically. But if names load on the sand, we can recover this sand very easily. This is the principle of the DX, And just before I talk about the waste plastic, is the energy level of the waste plastic decreased by the impurity, the mixture, dirty, the contaminant, something like that. But if we can use the traceability of the information technology, we can prevent to decrease the energy level. So we put the smaller energy toward the recycling. That is a significant advantage of the recycling by using the DX. Okay. So we have the three levels when I talk about the DX. First thing is digitalization. Just change the analog to the digital. So that we have the typical example is a manifest. The manifest is prevent the illegal dumping. So the past year we are using the paper, but the government changed the electric the manifest 20 years ago. But problem even now, penetration rate on only 80. Because this is only for this system only focus on the prevent in the illegal dumping. The company cannot get the money for profit. This is the main reason why not spread out. Okay, so the transformation is the most important thing. The people and the company have to get the money to get the profit. This is the very important driving force. Okay, so the next step is the digitalization. So we have some samples. So the EU recently planning to construct the DPP. Japanese government also tried to the Japanese version, the DPP, and the Catena or the blue plastic, and some their company and the government try to establish this kind of system. But this is just infrastructure to make the database. So the DX is using this data to make the profit. That is the most important things. Okay. So I like to show the small example, the Komatsu. So as you know, the Komatsu is used to be the construction machine company. Just sell the big machine like here. The chance is to sell this kind of machine a few times. So, but the business scale is not so big. But quite recent, they changed the business model like here. They contribute at the beginning of the business. So the measurement, the planning, construction, the report, and the maintenance. So they contribute the customer so many times. So they can they obtain the many opportunities to get the money, to get the profit, by using DX. So they install the data, the accumulated data in this kind of the data and the cloud. This is the real DX. So not only they keep the data, and that is not enough. So we have to use this data to get the new business. That's the very important point. So this is an example of the DPP, the recently EU tried to develop this kind of system. So the manufacturer offers the data, and the product retailer offer the product information. So the customer, if you like to see what kind of material the inside of this material, so they can see the information very easily, and recycle that also. And the customer sector, public sector, observed this behavior to check the everything. So this is just now they are constructing, but the Japanese government also construct a similar system. So this is the detailed structure of the DPP, and the manufacturer offer this kind of information, and the store the same things. They install the cloud, but sometimes they make the group like here to share the data. So it depend on the location, depend on the field, but that is not enough, So most important point, we have to make the common platform of the highest ranking, like here. So it means that, of course, this data excludes the personal data or something. But the important point is that everybody can use this common platform. This is just like big data. Okay, so for example, and this data, the city is the reserve of the material. So, for example, if we use the composition of the material and the customer data and the lifetime. So we can estimate what kind of materials come out the town. So the when, where. So we can prepare what kind of recycled the plant have to construct the where, and we can sort of forecast, this kind of the materials. And that is a very important point. And using the, the creative the new business to using this data. That is the most important thing with the DX. Just the accumulated data is not to make the new business. Okay, so that is the most important point. And the government, so the local government, observe the company's behavior. If this company goes well, so might be so we can reduce the interest of the tax, something like that. If it's not so good, so we increase something. So they can control the we make the company to go to the more environment issue. So this is the target of the using the DX. And this is the final slide of for me. So now we considered what is the good industrial materials. Now, previously we considered two things: good low price and good quality. That is the only thing we can see. We can understand this material is good or not. But in the future, not enough. We have considered environment and ethics. Okay, so environment means that even we make the same thing, we can reduce the consumption of the energy and the resources. But we cannot just see the materials. So it means that the question of the traceability is very important, and also that we have to consider ethics. Just like the human right, the gender of the but the ethics materials things. So even the environment ethics, we cannot understand, just see the materials. So certification and the traceability is very, very important. So this is DX support this kind of information. So again, in the future, price is the quality is not enough. We have to consider the environment ethics. So to consider that these two new factor, the DX is a very useful, powerful tool. And that is my presentation. Thank you. Thank you for kind attention.
Thank you very much, Professor Kamo, for the excellent presentation. So now I'm going to invite next presenter, Dr. Minoru Fuji from National Institute for Environmental Studies. Okay, so please welcome Dr. Fuji.
Sorry. Yeah, I have these are the contents of my today's presentation, and we have developed a guideline for digital transformation. Actually, we developed two kinds of guidelines. One is for business, the other is for municipalities. And today, I'd like to mainly talk about the guideline for business. So this is how can I say that some background and some the organization to make this guideline. So of course, it's time to prepare for the circular economy and also the carbon neutral society. So that is very important as well in the area of waste management. Okay. But you know the usually the how can I say the digitalization in the field of waste management and recycling is not so advanced. So we need to promote digitalization of that industry. That is our purpose, how can I say, motivation to make the guidelines. And this is the members to set the guidelines. So maybe roughly 2/3 of the members are from the researchers from universities and also some research institutes. So here also, sorry. So Dr. Osako, president of our society here. So also the rest of the 1/3 is from the kind of the groups of the industries. So the might be can I change the thank you. So objective is anyhow to help the recycling companies improve their understanding of DX and by doing so drive DX in the sector as a whole. And target audience is, in this case, main target is the manager class of the companies. But of course, other employees are also the target of this guideline. Okay. And this is some circumstance we are facing now. So, Dr. Kamo mentioned, so the plastic recycling is an important issue, and also we need to go green, so to achieve the carbon neutral society in the near future. But in the waste management sectors, so the business is not so efficient. And now we are facing the declining population, so which means, we don't have so enough workers for the recycling or waste management. So anyhow, we need to sophisticate the operations of the waste management. And some pandemic also they affected very much. But we have some opportunity to how can I say improve or achieve those targets by using the digital technologies. And we made some survey for the industrial management companies. So here the total number is 321 companies, and about 40% their annual sale amount is over 1 billion Japanese yen, and rest of less than 1 billion Japanese yen. And this is a result of the questionnaire, one of the results of the questionnaire survey. So the top is the some average of all the industries that was searched by some agencies. So compared to that, this could be the reference. So maybe top is the total of the among the waste management and the companies, and also the this is the case as a result of the larger waste management companies which sale amount is over 1 billion, and the bottom is the small companies one. So this, no answer makes a bit difficult to directly compare those results, but roughly speaking, in average, our how can I say who has the DX vision or strategy? This is the So the number of the company who has the vision for DX or strategy for DX is less than the average of the total industry. But if it is large companies, they are already have some vision, more than 36%. But if we see the small companies, only less than 10%, the company has the vision or strategy. So, there are so many small waste management companies in Japan. So the key would be how to promote the DX, the digital transformation, in those small companies. And this is, anyway, so we need to have some indicators to know the current status. So from the utilizing DX, so the ultimate purpose would be, for instance, green transformation. And we made some status assessment program. So yeah, if the company put their status to the questionnaires, so we provide some scores for their status. So for instance, vision, commitment, or risk management strategies. So actually, yeah, frankly speaking, it's a bit difficult to give the score. What is the, so here, so 100 is the maximum, but what is 100% achieved? So it's a bit difficult to say, but after the survey, so many companies did this, and then after that, we can each company can compare their result with the average scores. So at least relatively, they can understand the position of their company. So that's through this, system, so they can understand they need to do some more things, or they are the top group or not, something like that. And also, in the guideline, we mentioned about this offensive DX and defensive DX. Defensive DX means, anyway, the business is same as usual. But anyway, how to do that business is changed, sophisticated by the implementation of the DX, the digital technologies. That is defensive DX. So to do the same business, they can, for instance, reduce the number of workers, or they can reduce the, for instance, transportation distance of the waste collection and so on. That is a defensive DX. Offensive DX means utilizing digital information, they can create some new business. For instance, without accumulation of the data, it might have been difficult to, but that could be possible if they can utilize new digital technologies. That is offensive DX. That is also mentioned in the guideline. And through that several, how can I say, discussion, each company can create this kind of DX blueprint. We can start with very simple, this one-page blueprint, but that covers a bit wide areas. So of course, we need to have clearly defined the goals and roadmaps. That is very important. And there are some key goal, also key performance indicators, also operational processes, digital tools, what is important to achieve that there. So those also, important point is added value, so expected added value, or also the how much money can we save using the digital tools. That is also important. Anyway, through this how to say, comparison, how much investment we can do for the DX, that can be discussed. And from the this new clients to this admission awards. So maybe in each categories we can how can I say, discuss. So each company can discuss. Then how can I say, they have some plan roughly. Then after that, they can go a bit detailed discussion about the implementation of digital technologies. And also, this is also discussed in the guidelines. So anyway, we have data. So government or some public agencies have more data. And also each company, of course, have their own data. Problem is they are not shared or they cannot be disclosed. But ideally, if that information is shared by all the stakeholders, of course, such, and is that data accumulation can be contributed for the more, how can I say, precise tracking of the waste. Also, if we can know all the material flows related to the waste management or recycling, we can find some, how can I say, currently inefficient point. And that inefficient point would be the, how can I say, the room for the improvement. That is a business chance, I think. Also, this is made by some Ministry of Economy, Trade and Industry. So anyway, to promote the circular economy or also to achieve carbon neutrality. The collaboration between the Artel industry and also Venus industries are very important, I think. And currently, we start from the design of the product and manufacturing, sales, and so. So the final point is recycling, but actually we can start any steps. For instance, in the future, maybe we can start from the recycling, and that may determine the design of the product. So, well, to do so, anyway, we need to share the information. So for each step, we have so many related information, and those information are shared by the all the stakeholders. We can make the, we can say, the flow of the material or the products better. So, and this is the future for recycling. So the world is moving towards the circular economy, economic system in which products, raw materials, and other resources that were previously regarded were based are now considered as resources that can be recycled. While circular economy calls for decarbonization initiatives, it should be noted that circular economy also includes broader challenges such as the effective use of resources and regeneration of the natural environment. So I'm sure this order is appropriate. Anyway, start from the DX, we can have more, we can promote the GX, green transformation, and yeah, well, maybe circular economy may come first anyway. So DX will contribute for the green transformation and achieving, promoting the circular economy. So that's all. Thank you very much for your listening.
Thank you very much for your wonderful presentations, Dr. Fuji. And now I'd like to invite third speaker from Korea, SK Ecoplant, Mr. Dongmin Shin. He's going to present circular economy with digital technology and data from industry aspect. Please welcome with a big applause.
Good afternoon, ladies and gentlemen. I'm Dongmin Shin from Digital Transformation Department of SK Ecoplant. Thank you for all attending my presentation. It is also my pleasure to be here today. Today, I would like to present circular economy with digital technology and data. Before I starting my presentation, I would like to introduce my company, SK Ecoplant, shortly. SK Ecoplant is Asia top comprehensive environmental company, the world #1 fuel cell provider, and the Korea top 10 construction company. And the SK Ecoplant is leading SK Group's green business with the mission addressing global environmental and energy issues with waste zero and net zeros. Also, SK Ecoplant are now operating 10 WTE facilities in South Korea now. Okay, we think that there are two pillars for sustainable futures. One is net zero, another one is circular economy. But as you can see, fragmented value chain and inefficient operation hinder natural and circular economies. So under this circumstance, we think that solution is data and connections. Digital technology and data help us connect the dots and in achieving net zero and the circular economy. Okay. Focusing on circular economy, today I will introduce our two digital solutions. One is Waiver, another one is Zero for WTE, as in here, Waiver and Zero for WTE. First, Waiver. Waiver is a digital-based management solution for entire waste disposal process, which help us to manage waste to resource life cycle transparently and efficiently. Various stakeholders and more than 110 businesses are encouraging recycling rates through waiver services. Okay, Zero for WTE. Zero for WTE is AI-aided waste to energy operation control systems. Zero for WTE support optimal operation of a waste to energy plant. It has unique AI algorithms to provide operation guidance support with real-time monitoring. Zero Solutions, our vision is to innovate and advance waste to energy value chain by digital transformation. Zero is offering a variety solution for each steps of a waste to energy value chain, which increase our energy recovery rate and ensure the transparency of whole waste to energy value chains. Here is a sample graph of incinerators outlet temperature. Previously, incinerate used to exceed optimal temperature ranges, so cause air pollutant emission and shorten facility life. This is a reason that the optimal temperature is a range must be maintained during incinerators operations. So here, fast waste to energy plant operation used to rely on the individual operator's experience. But here, Zero for WTE solutions provide digitalized operation guidance with data and AI technology, and improves WTE performance. Operation status with the visualized AI solution guide is provided by analyzing and inferring real-time collected data. Our AI algorithm advanced by receiving continuous feedback from WT operation. WT also designed it to be implemented to be existing waste facilities with control system such as PLC and DCS. And these all systems are operating on the cloud system. As per the provided AI guidance, waste energy plant can be maintained stable temperatures to reduce air pollutant emission and increase energy recovery. According to our measurement in 5 waste to energy plant at last year, it resulted to reduce air pollutant NOx 12.4% and the CO is 49.7%. And the energy recovery increased. Steam generated is 3.1%. Zero for WT solutions are applied to 10 WT plants in South Korea and 2 WT plants in Malaysia and Vietnam. We are continue to promote the implementation of the Zero for WTE solutions in worldwide, including Japan. This is a detailed result applying the Zero for WT solution in one WT plant in South Korea. Sample data is show that the steam generation here, steam generation is increased 6%, and the air pollutant emission decrease and 42% and 74% by maintaining appropriate operation temperature. Lastly, SK EcoPlant digital solution is creating new values by connecting the stakeholders and utilizing data through services that enhance efficient and visibility in circular economy and natural areas. Beside waiver and Zeropod WTE, we have a Zeropod WWT. Zeropod WWT is AI solution for wastewater treatment and plants. Also, we are offering carbon management platforms and robotics solution for medical waste. Okay, that brings me to the end of my presentation. Today, I have shown you SK EcoPlant's digital plant for circular economy. SK EcoPlant is solving environmental problems with digital technology and data. That's all I prepared for you today. Thank you for listening.
Thank you very much for your excellent presentations, and showed some actual AI-based technology, how to improve the pollution control and pollution reduction and increase the efficiency of waste to energy plant. Thank you so much. Now I'd like to invite first speaker from Korea. His name is Dr. Hangmin Kim, and he's gonna present hydrogen production from organic waste using reforming reactions. Please welcome with a big applause.
Hello, hello. Can you hear me? Yeah. Hello, my name is Hangmin Kim. I'm working on Changwon National University. I'm sorry about the presentation instead of Professor Dae-Hoon Jung. By the way, I appreciate to invite this meaningful day. Let's start the presentation. Today, my topic is hydrogen production from organic waste using reforming reaction. These are contents for the presentation. Nowadays, human population is increasing in the world. Waste generation is also increasing because it is proportional to human population. But it is hard to treat the waste by traditional method such as ocean disposal and landfill, because ocean disposal has been inhibited by London Convention, and landfill, the area of landfill is decreasing now. Therefore, new treaties for the treatment of waste are required. Waste to energy is one of the good option to treat the waste and to produce energy. In addition, waste to energy can contribute to the carbon neutrality. Carbon neutrality indicates that carbon dioxide emission due to the human activity are in balance with the carbon dioxide absorption. To achieve the carbon neutrality, it is necessary to reduce emission of carbon dioxide and increase the amount of absorption by various technology. 134 countries have declared net zero until 2050. Korea and Japan also were participated in this declaration. So today, among the waste to energy, I will introduce waste to hydrogen technology from organic waste. Hydrogen energy has several advantages. I will introduce four kind of main advantages. First, it can replace fossil fuel in field of industry, electricity production, and mobility. And second, it is eco-friendly and clean energy because it produces less greenhouse gas when it is used as a fuel. And third, it has high energy efficiency comparing to heat engine. The last, it can be produced by from various sources. To produce hydrogen from organic waste, a sequential process is required. First thing is anaerobic digestion. Second thing is reforming of biogas. So I will show the two kind of research. First thing is optimization of anaerobic digestion. Second thing is optimization of reforming reaction. First research is anaerobic digestion. To optimize of anaerobic digestion, the type of reactor and agitator were investigated. We prepared three type of reactors. Type 1 it was cylindrical shape and equipped with pitched blade agitator. Type 2 was cylindrical shape and hydrofoil agitator. And type 3 reactor was cubical shape and equipped with hydrofoil agitator. The figure shows volume fraction of sludgy with current type of reactor based on CFD analysis. The sludgy volume fraction is affected by mixing efficiency. Among the prepared reactors, type 3 reactor shows the highest dispersion of sludgy due to the axial flow and turbulence flow. The table summarized the pollutant removal efficiency and biogas production in the different type of digestion reactor. By the comparison, type 1 and type 2, it was confirmed hydrofoil agitator exhibit a higher removal efficiency and biogas production. A comparison of type 2 and type 3 revealed that cubical shape is more effective to get the higher removal efficiency and high biogas production, resulting from turbulence flow. Second research is reforming of biogas. To optimize the reforming condition, we determined the main parameters. The main parameters were reaction temperature, oxidant for methane ratio, and oxidant time. Then the simulation was carried out using thermodynamic model to obtain the optimized condition. Finally, the validation of optimized condition was carried out. to optimize of oxidant, to optimize oxidant, the effect of oxidant was investigated. The biogas reforming, which is no addition of steam, it is hard to control carbon formation. Carbon formation should be controlled because carbon formation causes the deactivation of catalyst. So the steam is required. In biogas steam reforming, the steam for carbon ratio and temperature should be above 1.5 and 650 degrees C respectively to prevent the carbon formation. The relationship between reaction conditions and hydrogen production was investigated. Hydrogen production increased up to 750 degrees C and decreased thereafter. And hydrogen production increased with increasing steam per carbon methane ratio in biogas. As we saw previous slide, higher steam amount and higher reaction temperature is good for higher hydrogen production. But the higher temperature and higher steam amount require a lot of energy. So we consider the thermal efficiency. So therefore, 750 degrees C was the optimal temperature considering thermal efficiency, and steam per methane ratio was fixed 1.5 considering thermal efficiency and carbon formation. In these optimum conditions, we performed the catalytic activity test and deactivation study. We used the nickel magnesia serial zirconia catalyst, which was developed in previous study. As we can see in the figure, the methane conversion was very stable. So it indicates this optimum reaction condition is suitable to produce hydrogen from organic waste. So now we are planning to the research about the scale up because Sangwon City, our local government want to make the hydrogen production plant from organic waste. So we will study about scale up of catalyst production and plant scale and data accuracy will be carried out in plant. And finally we make the several scenario to optimize the effective and economical plant. Thank you.
Thank you very much for the nice presentations. So now we'd like to invite next speaker from online, Professor Shanlai Zheng from Tsinghua University, China. Professor Zhang, can you hear me? Professor Zhang, I think you're muted. So please activate your microphone and prepare for your presentations. I think he is online. I confirm his participation in the online, but any problem with the connections? Oh, okay. Professor Zhang, can you hear me?
Hello?
Hello, yeah, I can hear you.
Okay. Now it's for me?
Yes.
Okay. Sorry, just now I will go to another room. So I will start soon. Okay. Okay, so I will share my screen.
Yeah, please.
Wait a moment, okay? Okay, can you see my screen?
Yes, we can see your screen.
Okay. I can start now?
Yeah, please start.
Okay, thank you. Thank you so much. It's the pleasure to join today for the talking for the circular economy. 谢来正 from the Tsinghua University. My research focused on the waste management, recycling, and the circular economy. So today the talk is focused on the reshape global policies for circular economy. I think many professors or some scholars talk about this topic. So here I want to highlight some of the content for some from introduction to the eco design and the EPR recycling and the way forward. It's the 5 parts. But I will take a short time to introduce the topic, my insight on the point. Basically, this one is to tell about the introduction. We know the geological mineral and anthropogenic mineral. So our is the human history. Today we call it the Anthropocene epoch. But we know this is very short time to compare the Earth history. The Earth history we have is about 4.6 billion years. But for our Anthropocene that's 200 years. But in these 200 years, the human have changed our Earth. We have this to take out, maybe get the resources and the mineral from the underground or from the earth. You can find a very deep the petal. This carries some of the copper mass. On the other side, we find also many the cities growing in the different countries. Here I take the photos from New York a few years ago. So many is the buildings that growing in our the city. So that is the landscape changing from this earth, from the opposite to our the buildings that growing in the cities. So basically, we know this is to tell some of the material flow. We extracted and get resources from this sphere. After extracting, producing, manufacturing, and consuming, that with rest of end of life. This is the product waste could be for reuse, remanufacturing, recycling, or recovery to realize a closed loop that we call is the material flow. And we sometimes call reuse, remanufacturing, recycling, or recovery. It means the circular economy. But basically, we know our resource is the global material consumption is increasing very faster. About 50 years ago, we only have this 27 billion tons per year. But currently, maybe this data could increase for the maybe 100 billion tons. But this data also increasing very faster. Maybe in the years 2060, will reach 167. This is for the global material consumption will be increasing very faster in recent year in the near future. Also, we find another for this the results for the global resource reserve depleting. So in the global level, in the world level, so we find some of this data. For example, urban mines of natural earth, underground resources will go depletion, will go shortage, but above ground for the resource will go up very quickly. So this is for the world insight. From China, we also get this assessment. So we can find out for the lead, for the nickel, for the cobalt. So I think it's underground resources will go depleting very faster. But as the other side, we know for the global waste will generate very faster. So maybe for this country, in this century, the global waste generation will reach the peak. This for the global level. For the China level, we find for the e-waste for the data, maybe for the years 2040 to 2045, e-waste will reach the peak in the China. This is for the data for the end of life, include for the e-waste, the end of life vehicle, and the waste wiring and cables also increasing faster. Maybe at the year 2020, this data is 60 million tons, but this data will reach about 160 million tons. And to tell this is the data. So circular economy is very important to not only for the environment protection, but also for the resource security and the security for the supply chains. Basically, we know as the material could be is extracted for the designing, production, remanufacturing, or the distribution, consumption, collection for recycling again. So circular economy is charged not only for the resource efficiency, but also for reduce waste through for the anthropological circularity. So it is enabled by the two approaches, namely by the closed loop for the material circularity or open loop for the material reused for other functions. So this is for the basic that we realized for the circular economy. This is the framework. But today we talk about more and more about the digital circular economy. So digital circular economy want to materialize or visualize the material flow or the different flows. So it means we'll be visualizing a high resolution to tell about this the flows. And so in these flows, some of the policies or some of this could be adjusted to improve the material flows or to tell about the material recycling. So in this side, we have the different some is in the group level. We know we want to protect the environment. Basically, we want to know to tell about for the first one for the eco design, to controlling to the toxic release to the across the material life cycle. Basically, we know from manufacturing, from material selection to product packaging, we use the eco design to avoid some of this toxic material involved for the manufacturing. Maybe, for example, for electronics to use green electronics and the paper electronics. So it means eco-design quite important. It's very, very high hierarchy to enable to improve the circular economy. On the second side, we want to know about for the end of life to use the disposal, for example, to use the detoxification to avoid some of the toxic material, toxic substances released to the environment. This is for the kids. We use the CRT monitor after dismantling. We get a collection for the lead, high metals, get the recycling. So we not only environment protection, but also to get lead recycling. That is to reliable detoxification. Another case for the waste LCD. This is from the lithium silicon body for recycling, because we know that is belong to the hard waste. So that is use the reuse or remanufacturing. The quality of the material function can normally go down, but sometimes use additional process like the smelting could be needed to raise the material quality. The second part is the EPR. Its EPR could be to get the full action for a smooth circularity. So benefit extender producer responsibility authorizations to get the different the material and find with a higher recycling rate. Today, we use more and more the International Plus APP program. We can install this APP in the mobile phones. By this one, we can get is the waste the product or product waste or older one to take back for the higher recycling rate that enable the digital transformation by this using this way. So, but in China as a case, we know the collection for recycling from manufacturing for disposal, but China imbalance between funding levels and subsidies relate to an unsustainable EPR policy. So that's a huge gap in China policies. Also, for the international the flows of waste because the loss of responsibility. Previously, that's much more the waste. This is the move go to another country from the one country to go to another country to transboundary for the waste movement. But that's a escape about the EPR, the principle. The last one we want to talk, next one we want to talk for the recycling level. Urban mining is becoming more cost-effective than virgin mining. So because we know by the urban mining to realize the circular economy, we compare recently for the e-waste and for the end-of-life vehicle recycling or for the urban mining vehicle recycling. Basically, we find that is the e-waste or the urban mining is much cheaper than virgin mining to get this maybe metal recycling. Maybe when the urban mining is just 10% about the cost treatment charge of the virgin mining. That will be inspired for the material of all about urban mining is to push for the resource recycling from the urban mining, not from the virgin mining. So digital the transformation next for the classification of ancestral minerals is for the anthropogenic mineral is called the solid waste, one type solid waste, because we know underground resources we can classify for the reserve base or resources, but we don't have those the classification for anthropogenic minerals. So it could be use similar this the classification to realize that even to forget is the digital transformation can classify reserve base or resources for this point. In this point we get some research classification on anthropogenic resources. So this is getting the data we divided for some of these different sites for some of the metals, for example, copper, zinc, lead, some of this the nickel, cobalt, and some of this the metals. Use this the philosophy. So that is the classification of the anthropology resources for specific data. Next one we want to talk about is the energy saving and emission reduction of circular economy. Previously, we don't talk more about for the energy saving for emission reduction for the circular economy. But today, more and more for the carbon neutrality or carbon emissions to talk. So to compare the circular economy of virgin mining or urban mining about that, we can find the circular economy could be achieved for the urban saving and urban and emission reduction to compare of them. So that is we can use a digital transformation to get the precise the resolutions. So for the way forward for the future at the global level, restriction on the treatment and recycling of toxic material or substance and restricted circularity can be considered urgent for the efficient circular economy in the near future. These approaches need to be translated or integrated into United Nations Basic Convention. Although the spatial, temporal, geographic, and international dimensions pose major challenges for the effectiveness of circular economy, that's much opportunities to transition a digital transformation from the linear models to the circular models, increasing the innovations in technical and policy capacities. So thank you for your attention. That's all.
Thank you very much for your good presentation on global policies and perspective for circular economy. Thank you very much. And lastly, I'd like to invite the last speaker from Cambodia, Mr. Chum Bore. Is going to talk about big data for managing municipal solid waste. Can you hear me?
Yes, I can hear you.
Okay, it's on. Yours. Go ahead. Thank you.
Thank you. Yes, good morning, everyone, and thank you for giving me the opportunity to present what we are doing in Cambodia. So give me a minute to share my screen. So I hope everyone see my screen. Okay.
Okay, please start. We can see your screen.
Okay. So before I get started, maybe I brief myself a little bit. So my name Bore. I am the founder and managing director of a company called Luma System, based in Phnom Penh, Cambodia. Luma System is a technology company that focus on providing AI and GIS as a platform in order to aggregate and build an application based on the big data that we acquire. And from there, we model it and building an application or solution based on the data that we acquire or that we collected. So the project we have been done for the last 3 years is for Ministry of Environment in Cambodia, that solving the current challenging that we have is solid waste. We named the platform as a National Solid Waste Management Platform. So before we get into all the detail, I will show you step by step of the process, very quick, but I hope it's a little bit not too technical for everybody. So I like to start with the current challenging that Cambodia have. I think the challenge we have is is a little bit different from what maybe a lot of you have, because managing solid waste in Cambodia is still very early stage. We have still a very starting point of managing our waste. So so currently we do not have a reliable information about where are the business, where are the house, and how many house in each location, what is the business type. I mean, we have this information from different places that we can collect it, but it's not reliable. So it's very difficult for us to do a collection of solid waste in the city. So a couple of things that make us very difficult is we cannot estimate the cost to operate, estimate a total waste in each city or in each area. It's difficult for us to analyze and estimate the volume. We can't estimate the money that we can collect it from solid waste collection fee, from selling the different services to the community. And the top priority is that we cannot collect the payment from the user or from the citizen. I mean, we can collect it, but it's not up to the level that everybody pay the solid waste collection services. So for collection company, they also have difficult is the information. You know, in Cambodia, each province operate by a separate company, and the company who operate the collection or solid waste services, they own the customer data. Some place they own a landfill, and they don't have a proper collection zone or collection planning, and it's difficult for them to collect a revenue. So all of this is the challenge. So collection company also have a challenge, and authority also have challenge in collect all of this information. So we build a platform that allow everybody to benefit from using technology. First, we have the platform will allow the truck company to monitor their truck services, like where are they going, what is the schedule, which area that they need to collect 1 or 2 times, stuff like that. So this we use GPS technology, equip it with and connect it to the central system. So this information of truck location and operation will send directly to the landfill. Before, the landfill do not have full feasibility of how many trucks per day that need to come and dump into the landfill. They don't have proper information. So with this information, give a landfill a more detail of what kind of truck from which company, where are they coming from, and how many and the waste volume also will sent to the landfill directly, and everybody can see it. Also, in the platform, we build what we call it a driver application. So this one is tell the driver to know where are the zone that they need to collect and which point that they need to stop and collect the waste. Before we roll out the application, the driver did not remember that they need to remember manually, and they have to go manually of where they want to collect the waste. So with this application, help them to know exactly where they want to do it, where is their schedule, and where is the customer. So we build an entire business and resident application that monitor who need to pay the bill and who did not pay the bill, and how much each of the house need to pay. Also, there's an application for a citizen that they can check their own schedule for the house, when and what time, plus how much they need to pay. So this platform will allow local government to use it. Also, the Ministry of finance also can use it. So cross ministry or local authority, everybody can use it in this one platform. So this is the whole thing that we built, and the whole ecosystem of Cambodia solid waste services is relying on the platform that we are operating right now. So I'd like to brief you a little bit of a driver and collection routing app that we built. So every day, we will have, how do we have the collection company or the driver to do this? Is that a collection company will be able to access the platform that Ministry of Environment built it. And then we use the digital map with the data to show them the collection point. So so the driver can go directly there and collect it. But before we build this, collection company will work with local authority to define the time zone and the area that allow people to dump the solid waste. Because right now we do not have a specific time for each area that they can put the waste outside. So with the system is helping the local people to know that, okay, today I need to put the waste at 10 p.m. Tomorrow the truck is not come, so they don't need to put the waste out. So this is a small thing that we still facing a challenge to managing. Next is the driver application. So every driver, when they start their day, they have the mobile phone that they know where are they going. So in this example, the driver, they have to go to one street, they call it Kao Chanda Street, that have a length of 14.3 kilometers road. It's gonna take them about 2 hours to complete the task, and the driver need to do 50 stops for this route. And when they click on it, they can start their day in their collection zone, so they can go through step by step into the location. When they complete the stop, they can press finish, and then they move on to the next route. So with this application, is helping the company and the citizen know which truck they come and collect their house. For collection company, it's easy for them, because let's say if I am a truck driver and I feel sick today, I can just replace the truck driver, another one coming in, and then they can just follow the route that have been prepared by the system. So this is some of the small things that we did to ensure that the proper solid waste services will be provided into our local community. Next one is the application that allow the user to pay solid waste. In Cambodia, it's different from a lot of countries that we've been studying. Is that a lot of countries, some people pay solid waste by using a plastic bag, like they buy a bag and pay for that. Or some people, in some country, they pay with a property tax. Some country pay by the bin that they put. But for us, it's very difficult to justify for that. So each house will pay based on their location, type of house, and type of business that they operate. So in the system, everybody as a citizen can log into the system, I mean to the mobile app. And if, let's say I am a KFC and operate it, I can see my house. I can that there's a due payment into the platform that I can pay, that I need to pay my solid waste. In this example, KFC need to pay 10,000 real for their business. And I can go to pay bill. And if I have two locations, I can pay both location, or I can pay just one location. So this is also a very simple and small application for citizen plus the authority to manage the collection of revenue of the solid waste. So if I have a multiple property, I can pay all of my property in one application, in one app, or in one screen. Another small feature that we add is for the recycling purpose for general user, because right now a lot of people does not do a recycling. We don't do a waste separation yet. So with this application, we'll allow general user to log in into the application, and then they can check the waste collection schedule, or they can check on map. So if they can check, so either way they go, they be able to see their next pickup schedule at their house. And in the, you see there are three bin color: red color, blue, and yellow. This represent separate bin for recycling. We also show them the yellow is for recycle, red for organics, and blue for a general purpose waste. So in this, it gives information to the user where to put their waste based on the color. And also this gives information to the truck company that they need to use a separate truck to collect separate bin based on the collect separate waste based on the bin information and location. Yeah, so this is a very basic presentation for how do we build the data using AI and GIS together in order to solve our current solid waste management platform we have. Thank you. I am here to answer the question if you have.
Okay, thank you very much, Mr. Boley, for your very practical case of the waste collection applications. So now we have had 6 presentations finished. So we are going to move on to the Q&A sessions. We already got some questions from online, but I'd like to start to invite the question from the participant in Osaka in this hall. And then next we are going to move to the online questions. So if you have questions, please raise your hand. And we only have the microphone at the center of this room, so please go to there and give a question. And please say your name and who do you want to ask questions. So anybody have questions in this room? Okay, so
yes, thank you very much for all presenters. So very interesting and exciting presentation, I think. So I have many questions, but so I focus on just only 3 persons. Okay, one is Fuji Sensei. So today, so you show that so the Japanese Venus industry have many small companies. Yeah, normally, so it is difficult to so apply that new system in a small company. How do you think? How can we use that so digitalization and also DX and etc. to the small companies? Yeah, I would like to ask you that opinions. Okay. One, okay. So I have, so two. Okay, one by one, or
So, thank you very much, Takaoka Sensei, for the question. Not affect very much to their business. So maybe first they can start from the utilization of small bit, application. And it can efficiently reduce their work. It may help to start their digitalization. Thank you very much.
Well, again, okay. Yeah. One more
Continue to
question.
the second question.
Second question. Yeah, to the doctor. Yeah, SK plant. Yeah, today you showed that so a very good AI system to manage that waste to energy plant, and so you already applied at the 10 plant, etc. Yeah. So, do you already start at the remote monitoring or remote operating from centers? Yeah.
Thank you for your question. We are starting remote monitoring systems. We monitor our 10 facilities in one places. Just monitoring. Yes. We will move to the remote control system. Yes.
Okay. Third question, please. China.
Tsinghua University.
China. Professor Zhang, you have a question. You
Yeah.
have a questions.
Okay, so I'm very interested in that traceability system of waste. So could you tell me that so situation of that traceability system in China?
Okay, Professor Zhang, could you
Hello?
hear the
Yes, it's so want to talk about the recycling rate here?
Yeah, recycling and also disposal. Yeah, anyway, so could you tell me that so traceability system of waste and waste management recyclable materials?
Okay, thank you. So that is a very good question. So recycling rate is quite different, vary from the different type the waste type. So it means different type of waste have different type of rate. For example, I think it's for example, e-waste, electronic waste. So about is China, the recycling rate about 40 to 50% for the recycling rate. For the another type, for example, the end of life, the vehicle recycling rate much higher, maybe 60%, I remember. And the others type with mineral solid waste, I think it's just the collection. This is the for the recycling or disposal. I think maybe it's from the countryside for the cities, total together. I think maybe not more than maybe 40% or 30% to 40%. But totally for the other type of waste, because China every year generates about 10 to 12 billion tons for China. I remember the total all the type waste calculated about is not more than 50% for recycling or disposal. It means more than more than 50% is dumping, not a stock, not a recycling or disposal. That's totally the insight for the China waste management situation. Thank you.
Okay, but so could you tell me that traceability system? Traceability mean that so local government or central government
Yes, yes.
the information,
Okay.
etc. Yeah.
Yeah, China is the government to make a special the recyclability or special for the companies around China cover different type waste. Mostly, I think most of the times, Chinese government to make a very enough the capacity for the companies, but some companies cannot collecting some of the all the type of waste, the waste, because collection is not so easy. It's much higher the cost input. So it means for the majority the waste type, Chinese government for the designing this the waste recycle company, they have very higher the capacity. But mostly the policy for the collection is not so better. It's not so enough for the collection for the waste, because collection not so easy. That's hard. That's a long distance. Maybe, for example, Chinese for the West, it's a long distance to collecting the waste to the city center. So that is the problem.
Okay, okay. Thank you very much.
Thank you.
Thank you very much. Yeah, my name is Hamza. I'm from X Research Institute, and I had two questions. So the first one is for Dr. Fuji. So in your presentation, you mentioned about the two different guidelines, and there was one guideline for the businesses, and I was surprised that the number of businesses that have a strategy for DX is rather low, especially for SMEs. So if some small businesses in Japan, for example, want to do their own strategy, are these kind of guidelines available for them to refer to, and these guidelines, do they include some kind of information about how to develop such strategies for DX for these businesses? This is first question.
Okay, thank you very much for your question. Yeah, if they can read our guideline, yeah, it's available. So also maybe it could be at least in the future, it's be available online, I think. And so if they want to utilize, they can use. And then, yeah, in the guidelines, so maybe, yeah, so some instructions are there. So according to that, they can at least set some plan, the initial stage plan to promote some DX in their company. Thank you very much.
Thank you very much. Yes. And yeah, second question, sorry. So second question is for Mr. Shin from SK EcoPlant. So today you explained you introduced two different tools, right? And I'm interested in the second tool, the 04, I think, yeah, so for waste to energy. So you mentioned that you introduced it to some countries outside of South Korea, Malaysia, if I recall correctly. So when you introduce this tool abroad, did you need to make some adjustment to the algorithms, or is it just plug and use in other countries as well? So is there some specificities if you want to use it in other countries? So this is mine.
Thank you for your question. And we needed some modification for the local country due to the waste calorific value is different depending on the country. In Southeast Asia, has many how can I say, the high humidity in solid waste. So we will adjustment our AI algorithm for the country.
I have a question for Professor Kamo from Waseda University. And thank you for your excellent, insightful presentations. I know the plastic material recycling is very important in terms of energies and then other CO2 emissions and things like that. But I know Japan is much of plastic waste going to the energy recovery, and your country should make effort treating of all plastic waste from energy recovery to material for as much as possible. And you mentioned that some digital technology can promote that the transition from energy recovery to material recycle. But I would like to hear some practical or some good example of digital technology so that people or government can contribute the plastic waste treatment or waste management from energy recovery to material recycle, high quality material recycle. Thank you.
Thank you very much for my question. Okay, so you're right. So unfortunately, in Japan, the energy recovery percent is so high. Maybe the 60% of the plastic, unfortunately, incinerate. Yes, you're right. Okay, but the problem is that the Japanese recycler like to use the very high quality the plastics. So the low quality plastic, so that nobody likes to use this kind of material. This is one reason. So of course, present time we don't have this kind of system, but the important point is, that we like to know the exact composition of the best plastics. So I hope so. The chemical company have to offer some data for the inside of the plastics, so the customer, the recycler, can obtain this data, and so the recycler, this information very good for the separate high. They can obtain the very high quality the plastics. So the DX helps this kind of the data deliberation, so the distribution. So this is one thing. And another example was now we detect the, for example, the sorting machine. We use now the sensor, but this sensor only catch the major part of the plastic, and not the other minor products. But if there are some so putting some data in these materials, we can obtain the exact composition of the waste plastics. So if we recycler can obtain this data, they can separate. They obtain the very high quality, and not only major products but also the minor products. They can separate. So we can achieve the very high quality the material, the recycle rate also increase. I hope I like to achieve this kind of society. Okay?
Yeah, thank you very much. What about some perspective of production stage?
Yeah.
I think you or somebody presented the digital product passport.
Yeah.
So maybe some important
exactly.
plastic product should have product passport, so that recycling company can access those data for sorting and for recycling or whatever. So
yes. This problem is not only the recycler. So everybody must contribute to this one, to the company, to the manufacturer, and the store, and the customer, and the recycler, and the government. Everybody have contributed to this problem. And so I think we should do that. Yeah.
What about tax? Like you have bad chemicals additive to the plastic product. You should pay more.
Okay.
In the long run, in the long term.
I hope so. The cost should be the reduced. The low. Yeah. Of course. Yeah. Thank you very much. Thank you very much.
Okay, thank you. Any other questions from the hall? Please.
Thank you for presentation. I'm Reo Kamura from Economic Research Institute for ASEAN and East Asia. I'd like to make one question for Mr. Boré about Cambodian big data system. You are trying to establish some basement for waste management with leapfrog technology like digital system and applications. I'm curious about, are you planning to standardize this system into the whole waste management system in Cambodia? Like maybe this application should be installed for every waste collectors or waste management operators. Thank you.
Okay, Mr. Bolay.
Yes, currently the rollout has been put in place. So I like to separate the thing into different angles. So from the collection company perspective, currently in Cambodia we have put a standardized to enforce that all the collection company will need to install and equip with the platform that ministry have been built, that we build it. So so in summarize, right now we have like 750 trucks that operate across Cambodia have been connected to the platform. And most of that company already been trained and use the platform to manage their collection schedule, to manage their route. So that is from collection collection angle, meaning the managing the collection company. Another part in terms of managing the whole ecosystem, including customer, including collection schedule, including payment. We have put into 2 cities that implement it. So we have one in a city called Kampong Jam and another one city called Battambong have been fully implement this platform, and we hope to implement more city across Cambodia in the next coming year, because it take tremendous amount of energy and enforcement in order to roll out this application. I hope I answered the question.
Thank you very much.
Thank you.
Okay, so thank you very much for the question, and we have several questions from the online. So the question is to Professor Kamo, and the quest giver is Mr. Immaculate Javia from Port Moresby, first Secretary Governor of National Capital District, and his question is, what is your plan to help the to use your system to help the central government, and also the to help the waste management in the lower level governments, like local governments? Do you have any plans to help their policies, policy makers?
Thank you very much for the question. So yeah, good question. So this is not my turn. So because now there's some people here, so they're discussing what kind of the system to construct the DPP system to construct now. So maybe the another person is good for this answer to question. And basically, so just before I mentioned that, so basically everybody have to contribute. Every industry must be contribute, and also the how to say and the other thing that we have to use some private data. So of course the big data is very useful, but also it must be some risk. So the security is a very serious problem, this system. So how can keep the security? So that is a very important for this kind of system, the future. and the transparency. So everybody can see the the real data. That is the most important for this kind of construction system. So the practical the system is I'm not the member of the government, so I cannot answer the real one. So is that okay? So my answer is okay for you? Okay. Thank you very much.
Maybe one advantage for the national government for the transformation of digital technology for circular economy is that maybe government can assess the circularity of products and also some evaluate circular economy indicators, so that our society going to the right direction based on all the digital data. But there are very limited data available so far. So more data, more big data, so that we can access, we can use those big data by evaluating some the levels and the circularity of product in our society. This one maybe answer for the government.
Okay, thank you very much. And we have another question to Mr. Bolle. The question is material separation in different categories increase the recycling rate and reduce contamination in recyclables. So that means you have a separated collections. Do you have any problem of the contamination for the recyclable mixture of the waste in waste separation?
For now in Cambodia, we have a lot of problem with our major problem is the waste collection in general across the city is not 100% collected yet. So there's a problem that the recycling product have been dumped into the river or to different areas that people did not collect it. But that is before. So for now, with our platform, our top priority is to increase the collection rate in the city to ensure that all the waste, including all the plastic and other part of the material, have been collected all and put into one place. So with the new system that we put in place, we see a lot of increase in the volume. I think it increased almost 2 or 3 times of the volume that collected. But we did not enforce the waste separation from the house. The waste separation is been doing it at the landfill. So we see the recycling is increased. The number of recycling material increased when we collect more waste from the city, but we separate it at the landfill. So your question is correct, is that the number of recycling product that we can separate it at the landfill is increased based on the volume that we collected more. But we did not separate it at the customer site yet. Right now we separate it when the waste dumped into the landfill.
Okay, thank you very much.
Thank you.
So we still have several questions, but because of the time limitations, I'm sorry, I have to close this symposium. And before closing symposium, I'd like to share some thoughts to the participants. In this symposium, co-hosted by the Japan Society of Material Cycles and Waste Management and Korean Society of Waste Management, we are invited a lot of researchers, experts, and professionals from the business field. And during this event, we discussed about very high strategic point of view discussions to the very practical, innovative technologies applications for the sustainable practices to deal with the waste problems. And each talk is very helpful for us to better understand, and we know what to do, what we should do next. So in closing, I want to express my gratitude to the everybody in participating in this symposium. Thank you very much.
Thank you very much. Our society is rapidly changing with digital technology. So I think our digital technology can contribute from linear economy to the circular economy in a right direction. So we know that I think we have excellent speakers today and good discussions, and thank you for your participations, and have a good conference the rest of the day and the rest of week. Thank you very much for your contribution.
So thank you very much, Mr. Bole and Professor Zhang. We are going to close this symposium. Thank you very much.
Thank you. Yes. Take care.